It's question time. I think we'll go to that. And what's happening is I think we've got the PA system for another half an hour, so we can actually just have question time. So if anyone's got any questions for either Peter or Bill or Howard as well, that'd be fine. So we can start with, have we got any more from Facebook that we want to start with while you're thinking of a question? Oh, we've got one from Colin. Yes, Colin? Come up here for the microphone, righto. And I'll put that microphone there. Righto, Colin.
Peter, I wonder if you could go back to the graph which showed, I think, carbon dioxide and temperature for the 350,000 year period. In other words, the one which showed the recent ice ages.
I think I might have pressed a few unwise buttons here. So there might be a slight delay while I reconstitute something here. This is not stepping through slides. It's built from the database. So, actually, I pressed the button already, so I'll have to wait a little bit until it gets there.
Okay. I thought that what I saw was that the carbon dioxide concentration went up and down roughly with temperature. There may have been a slight lag or a slight lead, but basically there were peaks in the carbon dioxide which coincided with peaks in temperature on that particular graph.
So what timescale graph were you?
I think it was 350,000 year one.
Oh, way back. That sounds like Vostok. Yeah. Yeah, all right.
To 400,000 years, the temperature leads CO2.
That one.
By about 400 years. But in the deeper ice cores, to 800,000 years, the lag is about 1,200 years. So the CO2 is coming up 1,200 years after temperature.
Yeah, I'm particularly interested in looking at the CO2.
Hang on, that's the temperature one. Yeah. Vostok temperature and CO2.
Yeah.
The thing to remember there is that in Vostok, the CO2 sample interval is 1,100 years.
Yes.
So it's a bit hard to make pronouncements less than a...
What I want to know is, does anyone have any explanation for the variations in carbon dioxide? What caused the, say, 100,000 years ago, carbon dioxide levels to go up by nearly half as much again, from under 200 parts per million to over 290 parts per million? What mechanism caused those changes in carbon dioxide?
The only data sets that I could bring up would be Vostok has dust as well, so you can look at dust against CO2 or dust against temperature, but that just left me a little more bemused than before. Or you can bring up the Milankovitch cycles on top of those.
Some people are linking some of the little peaks, not the big ones. The big one is your 100,000 year eccentricity, but some are linking the smaller peaks to the angle change and some to the rotation of the angle, which cause changes in radiation.
I understand that temperature changes are Milankovitch cycles.
Yes, but some are then linking that then the
carbon
CO2.
dioxide following the Milankovitch cycles looks very suspiciously like temperature causes carbon dioxide emissions from the oceans.
Yeah, but the thing is, you're looking at 400,000, 800,000, right? You can't jump from that and say the temperature always leads CO2. In a non-linear system, over a short few years, CO2 can sometimes lead temperature.
Okay, we might have to leave it there, Colin. Thanks very much. Okay, Doug, and just for everybody, no statements, please. Just a quick question so we can get through as many as we can. Thanks, Doug.
Yeah, I'm Doug Cotton, author of the website whyitsnotco2.com, where I've offered $50,000 if anyone can prove me wrong. I'd like to suggest that we should be looking at a totally different type of data. We need to think outside the square. I want to give you in 60 seconds 3 types of data we need to look at. We need to ask ourselves why is hotter than Earth at the base of the nominal troposphere of the planet Uranus, which is more than 20 times further from the Sun than we are. How does the energy get there? I've explained it for the first time in world literature. I'm not going to do justice to it here. You can read my website, whyitsnotco2.com. Secondly, we need to ask, why does a study such as I published in 2013 show that wet regions are definitely cooler than dry regions at similar latitude and altitude, whereas the IPCC science implies a rainforest should be 50 degrees or more hotter than a dry desert at a similar altitude and latitude. And thirdly, we need to look at some totally different things, such as why are we talking about all of this radiation forcing? There is absolutely nothing in physics that supports the concept that you can add different fluxes of radiation and that they work as if a single source does the same thing. So we need to look at some evidence, some data. For example, ask ourselves, if one electric bar radiator at a certain distance warms our cheek to a comfortable 44 degrees, then according to IPCC science we could add 16 radiators and we get 357 degrees.
Yeah.
But obviously
in regard to the water vapour, we can see that right just across the continent, Doug, that when you go from the coast where the water vapour is higher, it's actually cooler. The minimum temperature is warmer than it is in the centre, where it's drier and less water vapour, and the maximum temperature is cooler than it is in the centre. And that's explained by the continental effect, which I'm not going to go into here. But there's no correlation between carbon dioxide levels and water vapour, because carbon dioxide levels are roughly the same across Australia, apart from some industrial sites, and water vapour varies enormously. So I'm going to ask Peter Bruun for the next question.
My question is the use of different isotopes for assessing long-term temperatures. I believe those temperatures going back to the start of the Cambrian, they're using they're different isotopes of carbon and oxygen. They seem to vary a great deal. Can you just tell us quickly a little bit about those, and why are they not used in a shorter time frame?
No, I can't answer that. I've certainly got some, well, there's quite a few temperature sets based on oxygen-18, and there's someone from solar stuff, C14, but I mean, I'm not the person to ask for that. I can look for, gradually increase my data sets on to do with isotope ratios, but usually I would look for them because they're a proxy for temperature or for galactic cosmic rays or for something else, I guess, would drive me to look for more.
You can certainly use oxygen-18, 16 isotopes over a short period, not just long periods.
Well, why has that not been done?
It is. It is being done. I've been in cores in Antarctica where we've done it. Absolutely.
But they keep talking about ice cores and
but the ice core is not giving you the land measurement. The ice core is the water that's coming from the Southern Ocean precipitating, so it's reflecting the oxygen-18, 16 isotope ratio in that Southern Ocean water that got evaporated and dumped in snow. It doesn't give you the temperature at the South Pole Station or at Vostok or anything.
Okay. Thanks very much, Peter. Next one, Jim.
I was at a presentation recently by David Thodey of the CSIRO, and he said early in his presentation that one of the chief functions of the CSIRO is to inform the public of science issues so they don't fall victim to scientific scams. On the other hand, he said he's also at the beck and call of the politicians. He didn't fully answer my question, which regarded the conflict of interest there. Are you, as a senator, able to take him to task on that very large conflict of interest?
Well, we can just assess his empirical evidence, and they haven't provided any so far. So after we've challenged them on their response to us, it's now up to them to respond to us. And so we'll see what they come up with, Jim. But we certainly can draw attention to the fact that they get a lot of money subject to their predictions or their claims, and that does create a conflict of interest. And perhaps Bill might discuss the Bureau of Meteorology's conflict of interest.
Sorry. What was the question? I'm a bit deaf.
Conflict. You want to ask it again? Conflict of interest.
It's basically a conflict of interest between the CSIRO, one of their chief tenets is to inform the public of basic science issues so they don't, that the public don't fall victim to scientific scams. On the other hand, they are also beholden to their funders, the politicians, and there is a conflict of interest there.
It's all a very complicated situation, really. I mean, I'm a data analyst, and I've spent ages on looking at temperature data, and I listen to some of the discussion that goes on, and I think a lot of it is simply redundant, because the underlying temperature data that everybody tries to relate to carbon dioxide has been measured in so many different ways that it bears no relationship to anything. It's simply a lot of random numbers being put together so they produce a trend. I mean, you can't possibly use Australia's temperature data set to depict trends when it's changed so much over time, which was one of the key themes that I was driving in my talk. Now, whatever CSIRO do, by massaging the data or claiming that it's good data or claiming that it's useful data, I have photographs of weather stations all over the place and historic photographs of weather stations in 1939 from all over the place. None of it makes any sense in the sense of joining some dots that says here's a logical trend. And if the temperature data can't be shown to be useful, then the other arguments about carbon dioxide and closing powerhouses and all the rest of the stuff all fall in a heap because there's no reference. So all this chatter about global warming, if the temperature data aren't up to scratch, then it's just chatter. That was sort of the theme of what I was trying to drive towards in my talk. So I'm a bit dislocated from some of the stuff that's being talked about here, simply because I know the data so intimately and know that it's not useful for the purpose it's being used.
Does that answer your question, Jim?
Yep.
Okay, let's get one from... Oh, sorry, do you want to say something, Peter?
Oh, no, go on when you want.
Let's ask another question from Facebook. Howard's answered this one from Carolyn Muir. Is the sea level rising? You want to answer that specifically for Carolyn Muir on Facebook? Howard?
Yes, the sea level is rising, but at a steady rate, like a ramp. The rate it varies a bit around the world. It's somewhere between 10 to 15 centimetres a century, and you can check tide gauges all over the world for that, but there's no sign of acceleration. So the idea that we could get to 90 centimetres or a metre by the end of the century is impossible. If you are in a car doing 15k an hour, the only way you can do 100k an hour is to put your foot on the accelerator. So it's rising, but so what?
Well, except for the ones where it's falling.
Oh, yeah. Yeah, but there are some places where there's land movements and the wind can pile up water over long distance over oceans and all that type of stuff.
But in Scandinavia, Chile, wherever, there are some long-term tide gauges where it's falling.
Yeah.
Mostly rising.
Yeah.
Is a good generalisation, except where it's falling.
And there are some data sets in Australia over 100 years now that are pretty much flat.
Yeah.
And the Queensland Department of Maritime Safety used to make available its data for Australia a few years ago, and they suddenly stopped when we were starting to draw attention to it. And it said that the average increase over about a 20-year span, 19-year span, was 0.3 of a millimetre increase in sea level per year, which works out at 3 centimetres a century, 30 millimetres, that much.
There's the Churchill Canada tide gauge going back to 1940.
And Rhodes Fairbridge, who's done a lot of work, who's dead now, did a lot of work on sea level, acknowledged for his work on that. He's shown that very rapid increases of as much as 2 metres or decreases of 2 metres happen in a very short period in Earth's recent past.
Okay, next question, thank you. Yes.
Hi, I'm Andrew. It seems like the data that we've taken from the ice cores, especially the Vostok, was it? Ice core? Is fairly central to our understanding of cyclical warming.
Well, on the 100,000-year scale.
On the 100,000-year scale, yeah. But the others didn't show such a strong cyclical shape. And so given that we've seen with more accurate and more tightly acquired data sets with the satellite data just recently, puts Antarctic and Arctic climate change at very kind of minimal levels in comparison to the rest of the globe. Is there any way that we can corroborate these ice core samples to match this mismatch, to address this mismatch?
Well, they cover quite. There's not very much overlap. I mean, the ice cores don't tend to come up to the start of the satellites very much.
I'm not speaking in terms of time. I'm speaking in terms of temperature. The temperature changes that you were showing in the graph just before were notably lower in Antarctic regions and polar regions than they were throughout the rest of the globe. That's where our ice cores are coming from, or am I incorrect in that assumption?
No, the ice cores come from Greenland or...
So if we can adjust our understanding of what's going on in the rest of the world based on those observations now...
I'm not trying to make elaborate computations or to second-guess things or go very far at all, really. I'm only sort of happy to say there seems to be an obvious correlation here, perhaps with a bit of lead or lag, or there doesn't seem to be any correlation. The impression I get from looking at all this data is things are awfully complicated and there seems to be very little flashes of insight available. I mean, the El Nino effect certainly is real. It changes temperatures all over the place. There are a bunch of other ocean cycles like that. I'm sure you can see they'll pop up if I look at correlations between those, but I'm not competent to go much further other than offering the data. Here's something interesting in the data sets that I find interesting. If there's a simple answer, I'd like to know about it. Or if there's a data set that goes against that, I wouldn't be at all surprised, but I haven't been able to find, looking away from the major ones, I haven't gone too far out, that there's lots of data sets starting to emerge now going back, well, particularly with temperature, 1,000 or 2,000 years from all parts of the globe. The Chinese, Indians, South Americans have ice coring and stalactites and tree rings and things. Stuff's coming up everywhere. There's hundreds of papers being published each year that address this sort of stuff that seem to be against the conventional wisdom that was around during the hockey stick era. There seems to be a whole new crop of climate scientists.
You'll notice that Peter doesn't speculate. He just doesn't. He's very, very disciplined in that. He just goes on data. And that's what science is decided by, the empirical evidence and measured data. For a Central England time temperature, the record goes about 359, 360 years, something like that, Andrew. And this shows nothing unprecedented there occurring recently. It just shows natural warming, cooling cycles. McLean, Carter and De Freitas put a paper out, I think I can't remember the year, it might have been 2005, 2008, I can't remember. They show that the temperature follows the El Nino Southern Oscillation Index with a lag of about 7 months. So it seems that over many, many different cycles, and Fred Singer, perhaps one of the best climate scientists in the world, he shows that there are many, many cycles, and then when you interplay those cycles, some are seasonal, obviously, some are daily, some are, as I said, seasonal, some are over 11 years, some are over 20 years, some are over 100 years, some are over 40 years. Queensland has floods every 40 years, roughly. And the past floods in the late 19th century were far greater than our recent floods. So there are many cycles, and what Peter's saying is that there are many cycles upon cycles and cycles, and when you put them all together, it looks like a mess. But there's nothing, the key thing is that the data shows there's nothing unprecedented whatsoever in temperature, nothing unprecedented in rainfall, snowfall, storm severity, storm frequency, storm duration, drought frequency, nothing unprecedented in ocean pH level, and there's just nothing happening.
And some of the responses that CSIRO made to your initial request for empirical data seem to be right against their brief about sort of not debunking science scams or anything.
Hello, Peter. We haven't got much time left. Okay, thanks, Peter.
Peter Spencer. It's interesting what they've all presented tonight. Man has always been threatened by other men invading him or a local disaster. Now we have this global phenomenon that is about to wipe us out. We're also in a period where we have more academics in the globe than we've ever had, not just in numbers, but in head of population. Now, these people are all being paid a lot of money to say this. If they don't say it, they don't get paid. Here we are saying it's all, you know what, not true. How do we, other than for doing what our new friend in the United States twitters, how do we get the news out that it's full of bull dust? Okay. Thank you.
Who wants to answer that?
I'm happy to answer that. First of all, I'd like everyone to acknowledge Peter Spencer, because Peter entered a long fast. How many days, Peter? 52 days up a pole down near Cooma in protesting the stealing of property rights by John Howard, using collusion by the states to avoid paying compensation. Peter's done that on behalf of thousands of farmers, and they should be paid billions of dollars, and it was done to comply with the Kyoto Protocol, stealing your land and other farmers' lands. It's still stolen, and that's one of the things that was driven by the same people who were driving this climate alarm. So I have to acknowledge that. How do we stop it? Just keep doing the things we're doing, which is getting it out. We're starting to have some impact now, even amongst the politicians, and Trump is having big impact. We're going to bust this, Peter, because we can now see the cracks emerging, and we'll see Mark Stefano and others from BuzzFeed and those people will come in here, tweet selectively, post a photo of one of my staff and say, look at these, whatever, but they won't talk about the science. We have now got the discussion on the empirical evidence up here in the Parliament and in the public domain, and we've been using those words for a few years, and they've latched. They're coming home, and so we just keep going.
Thank you very much. Last question, Peter.
Thanks, Leon. And Senator Roberts, thank you very much for a very interesting and enjoyable evening. It's great to be able to see all these people get together and get a good perspective on climate change. My question is about those satellites. I think, Peter, you said that there were 2 satellites, that they measured the temperature of the Earth from space. They use infrared technology, I think. And the data from those satellites suggests that there actually hasn't been any change in the temperature of the Earth.
I have a topic.
Or if there has been a change, it's been minimal. My wife says, oh, look, that's like measuring the temperature of the oven from the outside. My wife is an alarmist, I must tell you. And I was interested to hear Dr. Brady, when he was speaking, he actually said, and forgive me if the quote's not completely accurate, but I think you said you can't use satellites 400 kilometres up, you can't get into the stratosphere. So I'm a bit uncertain as to whether or not these satellite measurements are reliable.
It depends what you're measuring. The satellites to measure temperature use microwave beams, and so they can beam down to specific points and do it. But the satellites have a lot more difficulty trying to measure water vapour, and they also have a lot of difficulty trying to measure ozone levels in the stratosphere. So it depends what sort of instruments that they've got.
Right.
It varies a lot.
So is it fair to say that there's no agreement really about the satellites, or is some...
No. I think people are pretty happy with the temperature data from the satellites. They can't have the resolution for sea level. The ocean's such a wild animal, and a millimetre error is 10 centimetres a century error to start with. So it really depends what they're doing. It varies a lot.
I can flick up a few data sets here, not that we've got time to look at them, but I have a whole topic on the pause. From all the different data sets in different parts of the world, you can look and see whether you decide, is there a pause or isn't there? And then here's a trendlet diagram, so you can pick what data set or what time period to get the trend you want. So that's one way of approaching it. But the pause is obvious in some areas, in some data sets, not so obvious in others. The atmospheric levels, the satellites, both satellite systems measure 4 levels: lower troposphere, mid-troposphere, tropopause and lower stratosphere. And there's quite a difference between them. The lower tropopause the lower troposphere is fairly low. It varies from the tropics to the pole and throughout the season somewhat, but it's not that far up. So you're getting reasonably close, but there's quite a difference between, here we are, UAH, Northern Hemisphere, polar. There's the up high in the lower stratosphere, and here's down not too far above the surface. It's different. Here's the Australian ones at the same 4 levels. I mean, you can look at that.
The question is, can we rely on the data from the satellites?
Oh, yeah, I think so. The 2 satellite systems are quite different. They're in a bit of competition. They're reliable. It is a little bit different to what's being measured by the thermometer sets, but I could bring up graphs showing both sets together, and they correspond pretty well.
Satellites are regarded as reliable, very reliable, on temperature.
Yes, on temperature.
Yeah, definitely.
Anyway, thanks again for a very interesting presentation.
You're welcome.
Okay, well, we're just rounding out of time. The staff have to pack up and be out of here in 2 minutes. So we'll just keep going, just have a bit of a chat, but I think we'll just give everyone a round of applause that's been here tonight. So thank you very much. So our microphones will probably go off in a very short period of time, but in the meantime, we'll just, I'll hand it to you, Malcolm.
Thank you. I'd like to thank everyone for coming today. Some of you have come from a long distance, and I'd like to thank particularly our presenters, Peter Bobroff, Order of Australia Medal, Howard Brady, and Bill Johnston, very much. And the conclusion I take is that there's nothing unprecedented happening in anything we look at, nothing at all. And I invite you to make your own comments. Hang around. We will lose the sound.